Assalamualaikum and very good evening to my lecturer, Technologist Sari Muhammad Fauzi, and my fellow friends. My name is Muhammad Fira Aziz Muhammad Fauzi from DKP4, matrix number 01 DKP 32F 2001. Today we're going to dive into essential types of diesel engine cycles, which is 2-stroke and 4-stroke diesel engine. First, let's come up with the 2-stroke diesel engine. This engine completes a full cycle with one upstroke and one downstroke. As you all know, this engine is mainly used on ancient types of vehicles, also vessels. As you all know, the famous motor in Malaysia, Yamaha RZ, use this type of engine to stroke because it generates more higher power output with also strong performance. And now we're going to talk about the 4-stroke diesel engine. Also, when we talk about 4-stroke diesel engine, it requires 2 upstroke and also 2 downstroke. 4-stroke diesel engine is common use in nowadays vehicle such as cars, motors and also large ships. Although it's a bit more complex than the 2-stroke engine, but the 4-stroke design is more fuel efficient and it's widely used in vehicles where efficiency is key. Coming to the summary, both types have unique advantage, which is why they're chosen for different applications, from high performance machinery to everyday engines. Now let's break down into the 2-stroke diesel engine cycle into its 2 main stages. First stroke, intake and compression combined. In this first stage, as the piston starts moving upward, intake ports or valves open, allowing fresh air to enter the cylinder. This intake process is often assisted by a blower or turbocharger, which helps clear out any leftover exhaust gases, a process known as scavenging. As the piston continues rising, the air in the cylinder gets compressed to high temperature and pressure, preparing it for the fuel injection. The second stroke must be combustion and exhaust combined. At the top of the compression stroke, fuel is injected into the hot compressed air. The heat is enough to initiate the fuel, creating a powerful explosion that pushes the piston down, delivering the power stroke. As the piston moves downward, the exhaust ports or valves open, allowing the exhaust gases to escape. Fresh air then enters, setting up the next cycle and keeping the engine running smoothly.
Okay, my name is Kavindraj Anlaki Subramaniam. My entry card number is 01DKP23F1028. Now I'm going to explain about the 4-stroke diesel engine cycle. Okay, for the first stroke, the piston will move from TDC to BDC. As the piston moves downward, the intake valve open and the fresh air is drawn into the cylinder as the piston descends. Okay, for the second stroke, the piston will move from BDC to TDC. While the piston moves, the air valve will be closed and the air inside the cylinder will be compressed. This raises the air's temperature and pressure. This will help to prepare the air for combustion. Okay, next is the stroke, the power stroke. In the power stroke, the piston will move from TDC to BDC. Near the end of compression stroke, fuel is directly injected into the highly compressed hot air. The high temperature ignites the fuel without the need for a spark plug, causing a controlled explosion. The fuel injected in the cylinder will be atomized for a proper combustion, and the rapid expansion of gases from the combustion pushes the piston down, generating the power needed to turn the crankshaft and produce mechanical energy. Okay, the next is fourth stroke, the last stroke, that is exhaust stroke. At the exhaust stroke, the piston will be at BDC and it will go to the TDC. While the piston moves upward, the exhaust valve will be open and the piston pushes the spent combustion gases out of the cylinder. Once the piston reaches TDC, the exhaust valve will be closed and the cycle is ready to start again with intake stroke, the next and new intake stroke. Okay, now I'm going to explain about the comparison between 2-stroke and 4-stroke diesel engine cycle. For the 2-stroke engine, it will generally less fuel efficient due to overlap of intake and exhaust strokes, leading to a fuel wastage, while the 4-stroke will be more fuel efficient as the complete cycle ensures the better air-fuel mixing and combustion. The next, simpler design with fewer moving parts, but it can have more wear and tear due to continuous operation. This is for 2-stroke, and for 4-stroke, more complex with more components like valve, but typically has a longer lifespan and better durability. Then for 2-stroke, higher emission due to incomplete combustion and mixing of exhaust gases with the intake. For 4-stroke, lower emission as each stroke is separated, resulting in more complete combustion. Then for 2-stroke, requires more frequent maintenance due to higher wear and higher oil consumption. For 4-stroke, generally needs less frequent maintenance and is more cost effective to maintain over the long term. Okay, now we are going to see about 3 things required for a proper combustion to take place. The first one is adequate air supply, that is oxygen. The second thing is proper fuel injection timing and atomization. The third one is sufficient temperature and pressure.
My name is Shaktish, son of Rajagopal. My matric number is 01 DKP22F1005. Here I am going to explain about adequate air supply. For 2-stroke, due to the shorter intake process, effective air scavenging is important to clear the exhaust gases and ensure a fresh supply of air is presented for the next cycle. For the 4-stroke, air will enter the cylinder, so it make it easier to achieve proper air to fuel ratio for combustion. The next is proper fuel injection timing and atomization. For 2-stroke engine, fuel injection typically occur at the end of the compression stroke. Proper atomization is crucial due to the shorter combustion period. And for 4-stroke engine, fuel is injected at or near the end of the compression stroke. The 4-stroke cycle allows for better control over injection timing, leading to more efficient combustion. Sufficient temperature and pressure. For 2-stroke engine, compression happens quickly due to the shorter cycle, so maintaining sufficient pressure and temperature during the compression stroke is vital for proper ignition. And also for 4-stroke, the longer compression stroke provides more time to reach optimal pressure and temperature levels, which help ensure reliable ignition and complete combustion. Thank you.
So in summary, as a conclusion, the 2-stroke diesel engine completes its cycle quickly with higher power output in a compact size, making it ideal for heavy machinery, marine applications and situations where higher power in a small form of essential. While the 4-stroke diesel engines operates more efficiently with better fuel economy over longer periods, making it a favorite for cars, trucks and other everyday engines where fuel efficiency is a priority. Each engine type is designed to meet specific needs, from the power-focused 2-stroke for industrial use to efficient 4-stroke for daily driving. Understanding these two cycles shows us how different engineering approaches can meet diverse requirements in the real world.